name is John Van Sickle. Just to tell you a little bit about me, I used to work, I'm retired now, and I used to work for the EPA in the Corvallis Western Ecology Division lab, and I helped develop some of the methods for analyzing NARS data, hence my involvement in this webinar and in delivering a workshop to you at the upcoming Water Quality Monitoring Conference. The purpose of this webinar is just to introduce those of you who are really unfamiliar with R, the R statistical computing language, to that language, and just to learn to navigate around in the software a bit. We're going to save all the data analysis, all the hard stuff for the workshop, but I think you'll have a jump start if you get a little bit of experience and a little familiarity with the R language and the R Studio environment. I think Tammy's already told you something about the logistics for asking questions. If you can just type questions in the little box, then I'm going to stop at various points and ask whether there are questions, and we'll see what comes up, and I can respond to them. I believe, if I'm not mistaken, that Tammy will be recording this. Is that correct, Tammy? Can you?
Yes, that's correct, and I'll upload it to our site and give you the direct link. The attendees and everyone, and there are a few who cannot join us who will also be receiving this.
Yeah, so those of you who have who've been unable to install the R software, the R Studio software, or even if you have been able to, some of you might find it easier just to watch rather than trying to follow along exactly on your own computer, and then later on you can view the recording instead and take your own time about working through some of these things. Okay, let's go ahead and get started. I'm going to assume that you've all received from Tammy the pre-workshop instructions about how to download and install the R software and the R Studio software. So that's our starting point, is that you've got that software downloaded and installed on your computer, and you can see on my screen, right smack in the middle of the screen, there are two icons, one for R and one for R Studio. There are other ways to launch these from the Start menu. If you didn't get an icon for R Studio in particular, you can launch it from there as well. We're going to start, though, by launching the R software. So we just click on R. To launch the R software. And this is the workhorse. This is the program that does all the statistical calculations and the computing for us. You can see this little box that opens up this window called the R console. That's where all the action occurs. And you'll see a little prompt, a little red caret sign or a greater than sign. If you go to that point, let's just do a calculation. Let's just do 7 plus 5. And hit enter. It gives you the result right away. It displays it right to the screen. Just for now, ignore that little 1 in brackets. We'll talk about what that means a lot later. And you can do another calculation, 8 times 4, and so on. This is the R environment. The reason I'm mentioning it is that most of the tutorials. Who hasn't started?
Sorry, we had someone join that wasn't on mute. I apologize.
Most of the tutorials, okay. Most of the tutorials in R and the aftermarket books in R that you can get, you'll find a list of those, by the way, or some of them, at the end of the second instruction PDF that Tammy sent you. If you want to learn more about R on your own, most of them will be working in this environment. We're not going to be working in this environment because we could, but it turns out that there's another environment called R Studio that will take care of a lot of the bookkeeping stuff for R much more easily. So we're going to work in the R Studio environment. So let's close this program and open R Studio. To close it, we click on File and Exit. And just say no to the question about saving the workspace image. We'll talk about the workspace later. So we're back to the main desktop, and now let's launch our studio. And you see what comes up are 3 panes now. The left one is the left big one is that same R console that we saw earlier, and it operates just the same as before. We can type in a calculation like this, hit enter, and so on. And again, this is where the calculations will be done, is inside this console window. And the right 2 windows, the upper and lower window, are 2 locations that have a number of tabs on them that we'll use to do a number of bookkeeping and housekeeping operations in R to make it simpler. We'll learn about those as we go along, but for right now, we won't need them just for this very minute. Let's go back over to the console, and you need to click in a window pane usually to kind of activate it. And let's talk a little bit about a couple of simple R commands. So far we've just used R as a pocket calculator essentially. Let's do something a little more sophisticated. Let's assign a value to a variable. So let's define the variable x, and right next to it we're going to put a less than sign and then a dash, and together those form a left-facing arrow. Then let's just put the number 3. What this command means is define a variable x and assign it to have the value of 3. That you can think of that left-facing arrow as like an equal sign. It's an assignment statement, and whatever's on the left of that arrow is assigned to have the value that's on the right of the arrow. So if you hit enter, now you notice 2 things. First of all, nothing happens in the screen that you're in. And instead, up in the right-hand window, in the Workspace window, if you haven't clicked on the Workspace tab, click on that tab in the upper right panel. You'll see that we've defined a value x, and it's equal to 3. R has calculated x and set it equal to 3. And it's stored that in the R workspace. The R workspace is in your computer's random access memory, and most modern computers have a huge amount of space for storing all kinds of R objects. This variable is an example of an R object. And so what we're going to do is fill up that workspace with all kinds of things we calculate, and they're temporarily stored there until so we can use them again, and they'll remain stored there until we quit this session of RStudio in R. Let's go back to the console now and define another variable. Let's define y as 4. Oops. You notice that I use a little bit different spacing between the letters and the numbers. The blank spaces really don't matter in these commands, except in a few cases that I'll tell you about later.
John, we did have one person just ask a real quick question, and it says my tab is environment, sure, not workspace.
He says,
it says my tab is environment, the tab you're referring to on the right where it says workspace. Their tab says environment.
Oh, really? Well, it's possible they have a very updated version of RStudio.
Okay, we've had several, 3-4 people say that very same thing. So it looks like it's saying the new version says environment.
Oh, well, okay, I better get myself updated.
Yeah, I'm having several.
The key thing is it showing the same information, that the there's x is equal to 3, and now when we hit enter over in the console, we're going to define y as 4. That's the key thing, whether it's showing the same information. Maybe one of those people can respond.
Yes, it is. However, we had one person say that it's not. So, but everyone is saying they're seeing the same values as yours.
Okay, good. Okay, well, let's see.
I'm just going to take
I
Peter off of
think
mute
that,
because he's not seeing those values.
okay,
Okay, Peter, what are you
Peter, you're
seeing
not
in,
seeing those values?
yeah, what are you seeing on the right? I've unmuted Peter.
He may not
Oh,
have
his
a
mic is not
microphone
working. I
available.
apologize. His mic isn't working. Okay, so let's just keep going. It looks like most everyone's is showing the values you have.
Okay. I apologize, folks. I will have to check my version of RStudio and bring it up to snuff. I didn't realize there was some very recent switch. The version I have is quite new, and I didn't realize this is happening. Anyway, I think most of the functioning will be the same. Let me just ask those people quickly if they see up in the upper right panel, they see a tab called Environment, then there's another tab called History. And if in the lower right panel, they see tabs called Files, Plots, Packages, and Help.
Okay, so I'm going to unmute
Maybe
Matt Stover because Matt is explaining to me what's happening. So if you can hold on just a moment. Okay. Let's see. Matt, are you? So, okay, it looks like there's a little bit of discrepancy here on what people are seeing. I'm getting a lot of questions. So, Ben Holcomb, I've unmuted you. Could you explain what's going on, please? Ben? What Ben has said is the newest version is beta, and JVS is the most important, is the most updated that's approved. And sorry, Ben says he does not have a mic.
Well, if someone's using something that's beta, I'm using the one that's most recent that's approved. They may just have, I'm not going to use a beta version. They may just have to go along as best they can. I think that the kinds of functioning we'll talk about today should be available in both versions. I don't know what the beta version is at all.
Okay.
And but I'll look into this before the workshop.
Sure, that'd be great. We'll go ahead and continue. So
okay.
Okay.
All right. I think those of you who are seeing something different on your screen, I think you'll just have to see if you can adapt for now, and we'll check this out later. So going back to the left console, we've defined a new value of x. We've defined a thing we'll call y and set that equal to 4. And now let's define z and set that equal to x plus y and hit enter. You can see over in the right panel where it says environment or workspace now, there's the value of z, which has done the calculation. You notice that none of these values has shown up. They show up in the workspace, but they're not showing up on the console screen. When you assign a value to a variable in R, the command says just assign the value. If you want to see what that value is, the command to R is just type the object that you want to see, like just type Z at the prompt and hit enter, and it shows what Z is. Or you can type X and hit enter. It shows what X is.
And I just had someone tell me that if you do have the version that shows environment and history, the environment tab is not showing. However, the history tab does show those values, or show those values that you're seeing. So you may have to go to history screen on that.
Okay, thank you, Tammy. So going back to the console now, what we've done already is we've got a series of commands that we've performed, and already we can see that we could keep on typing commands and doing fairly lengthy and complicated calculations. But the problem with that is that we're not, in the real world, we're going to have a long series of complicated commands that occur one after another. We need some way to store those, edit them, and distribute them around so that we have a record of our work and we have essentially a computer program. And those sets of stored commands we're going to call a script. So let's start working with a script. And the way we do that is we'll open a brand new window that will be a script window, and we'll type the commands in there instead of typing them in the console. So to do that, go up to the upper left corner and click on File, New, and R Script. This opens a fourth panel that we'll type commands into, and this will be the script window. One thing you might have just seen me do there for a second is you notice that if you go to the boundary between the windows, you can resize the windows horizontally, and you can do the same thing vertically. And this becomes useful when you want to emphasize information in one window or another and you don't have a huge screen. So let's go back up to our script window now, and let's type those commands in again that we did before. X will assign the value of 3, hit enter. Y will assign the value of, what was it, 4, hit enter. And Z will assign to be X plus Y. Hit enter. Now you notice that when we've done this, nothing's happened down in the console. That's because all we're doing is imagine you're typing in a word processing document. Think of this upper left pane as like a text editor or word processor. That's really all it is. It's a place to type commands and store them as a script file and edit them. If we want to actually execute the commands, we need to somehow send them from this window where they're stored as just pieces of text down to the lower left window, which is the console. And we do that by highlighting them like this and then hit the Run tab or the Run icon. That sends the commands down into the console window and executes them. Okay. This is a good place to stop for a second and see if there are any questions. Anyone have any questions they want to pose at this point?
Apologize, I have to unmute myself.
Anything showing up for anybody?
Nope, it looks like some people are seeing exactly what
Okay.
you're seeing, and it looks like I just sent a chat out to everyone about the most recent version. And then there is a question from Philip Trowbridge and Matt Stover. Matt Stover asks, just to be clear, do spaces matter?
Spaces don't matter between variables. For example, we could just as well type this as Z space assignment. We can't put a space between the assignment because think of that assignment as a single symbol that's made up of 2 keystrokes. So it's got to look like this, I'm pretty sure. And then we could put spaces like this and we get the same result. There are some places where spaces will matter when we name functions or when we name variables, and I'll show you some examples of that later. But in terms of having separate sets of symbols, they can be separated by spaces. So line 4 is exactly the same as line 3 in terms of what it actually does.
We have one other question. Do you need to have R running while you're running RStudio?
Oh, I'm sorry. I should have mentioned that. No. What happens is when you launch RStudio, it automatically launches R and puts the R console inside itself. It puts the R console in the RStudio left window. So R is running now. You can see that if you scroll back up in the lower left panel. That's the same screen that you got to start up when you launch, if you launched R by itself. RStudio has launched R and put it inside a window inside RStudio. Okay? Good question. Thank you.
That's all we have right now.
Okay. So let's since I think the next thing let's do is we've got a little script up here in the left panel. Let's figure out how to save it so we can recall it later, and then we'll add some more commands to it in a little while. To save a script, we first have to figure out where to save it. That is, where and what file system to save it. And so we can do that kind of setting up the file, the folder on our computer where we're going to save the script and we're going to save other R-related information down in the lower right panel. You can see in my lower right panel I've got the Files tab marked, and it's showing a piece of the file system of the computer. Depends on your computer how you've got it set up. This folder that you see right here, in my case, is my Documents folder. But it really doesn't matter where your folder system is. And what let's do is let's create a new folder into which we're going to put all our R-related information. And you can see there's a sub-tab called New Folder. Click on that. Enter the new folder name. Let's call it Webinar. And OK. And you see in the lower right panel it's created a new folder called Webinar. Now let's navigate to that folder. Just go to the name of the folder and click on it. That moves us into the Webinar folder, as you can see in this bar right here. Just so you know, you can do more general navigating around your folder system in this Files pane by going way over to the right. See this little box with the 3 dots? If you click on that, you get a file structure tree that you can navigate around and move to different folders in your computer. So we've got our file system window set up in our new folder called Webinar. The next thing we need to do is we need to tell R that we want to use this particular folder as the place where we want to store our R scripts. The other thing it'll do is that's where the well, let's do that. This will be the place we store our R scripts. And so to do that, we click on More right here and click on the option Set as Working Directory. It didn't really change anything in the right panel, but you can see down in the left panel, doing that executed an R command, which is to set the working directory to be this Webinar folder. What that means is that unless we tell R differently from now on, all of the scripts that it saves or its scripts that it tries to open, or we're going to learn how to save the workspace, that will be saved in this folder. When R goes to read data sets, it will try to read them from this folder. So this is a handy way to put all your information related to a particular R project in one folder and then just work from it easily interacting with R. So now if we try to save this R script, it'll try to save it in this folder down in this Webinar folder. Now let's save the script. To save the script, we go back up to the upper left panel and kind of activate it. Just click on it. And now click on File, Save As. And you can see that it comes up with the folder that it wants to save as being the Webinar folder. and now type in the file name. And you can make up any name you want. However, let's type in webinar example. For a suffix, the convention is to use .r, like you would use .doc for a Word document, and click Save. And the file, the folder file is saved over on the right. I'm sorry, the script file is saved over in this folder. Just to double check that that's working the way we want to, let's close out the file up in the leftmost upper pane, like so. Just close it. The script window disappears because we've closed the script. If we want to reopen the script, we just go to the file down in the lower right pane and click on its name, and it reopens the script. So that's how you get back to a script that you've already saved when you stop RStudio and start it again. Any questions at this point?
We do not have any questions so far.
Okay.
One comment that it's good stuff, though.
Oh, okay. Good. Okay. So let's learn a couple of learn a couple of new features of simple features of R commands, and then talk about how to get out of R in RStudio. To me, the single most important reason that I work in a statistical computing language like R, and I also work in one called SAS, rather than in some kind of a spreadsheet, the single most important reason is documentation. R has the feature that you can type in a command that is not executed but is just a comment. So let's try an example of that. Let's enter the line below the next Z. Let's type a £, and then we're going to type an example showing that R is case sensitive. This is what's called a comment line. And if we were to run this line, if we highlight it and then press run, it gets echoed down in the console at the bottom, but nothing happens. R doesn't do anything. So it's a non-executed comment, and that means that we can use this technique to document all of the commands we're doing as we build up a script program. This is a very powerful feature of R. One of the things you will notice when you look at the scripts that we're going to use in the workshop, if you look through them, you'll discover that about 80% of the text in those scripts is comments, because I felt it was very important to explain as thoroughly as possible what each step was doing and how it was being done for analyzing NAR's data. So let's carry on with this example showing that R is case sensitive. And to illustrate the example, let's just type lowercase z. That's still just a comment, isn't it? We're not actually doing that. We'll go to the next line now, hit enter, and type the letter Z, and hit enter. Again, nothing happens because remember, we're in the script window. So if we want to execute this command, we just highlight it and hit run. Okay? And that shows us that Z is 7. Now let's do another command. Let's do type uppercase Z, enter. This time we'll enter an uppercase letter, Z, looks almost the same, and execute that command. And we get an error. And the reason is that R is case sensitive. When you type lowercase versus uppercase letters, they mean something different. They're defined as something different. You notice that the error message, This also introduces us to making errors in R, which we're going to do, which you do a lot of when you're developing programs in R. But you really can't hurt anything. You can always fix it and run the command again. The error messages in R are in red print when you do it inside R Studio. And you notice that the error message is a bit cryptic. It doesn't tell you that you typed the wrong letter case. It just says it can't find the Z object. And that means that capital Z has not been defined. But you have to figure that out yourself, that you made a case error, you typed uppercase when you meant to type lowercase. So one of the real skills in working with R, and one of the parts of its learning curve, is learning to decipher its really cryptic error messages. And we'll try to do some examples during the workshop that will help out with that. We'll make some deliberate errors and see if we can figure out how to fix them. So here's our script now. We've got this example showing that R is case sensitive. You notice we've modified the script. We've typed some more commands in. So the script name is now in red with a little star, which means that what we see on the screen in script is not the version that has been saved. If we want to save the current version, we just click on the little save icon, or click File as well, and that saves the script, updates the script. Okay. So we've saved our script, and if we wanted to stop R right now, that would be easy enough to do. But let's save something else. In this case, we can recreate our values of X, Y, and Z just by, when we stop R, we could start it again, or R Studio, I mean, and then load in our little script and run the script again, and we'll get our values again of X, Y, and Z back in the workspace. That works fine for simple situations like this. When we do the NARS workshop, we're going to discover that we're going to run scripts that are very long and very complicated, and they build up a tremendous number of objects over here in the workspace. And it would be nice to save all those objects so that we can stop and restart where we left off. So let's also learn how to save the workspace itself. And to do that, those of you who have where it says environment, I'm hopeful that there is a little tab, a little icon in the environment showing a picture of a little old floppy disk that is the save icon. If you click on that icon, you get again the window opening up as a location to save, and again it's going to be in the webinar directory. And let's call this file name webinar work. This time we don't add a suffix, and you'll see why. Just call it webinar work and click save. Down in the lower right window now, in the files window, you can see that that workspace has been saved where it tacks on a suffix of capital R, capital D-A-T-A, R data. That is a file that's in our workspace. That file cannot be opened in a word processor. It can only be opened by R, or R itself, or R is run by R Studio. But that file is totally transportable. You can pick up that file, move it to another Windows computer, move it to a Mac, move it to a Linux computer, and that workspace will open up in R, run on any of those platforms. So we've saved our script, we've saved our workspace. As our final little action before the break, let's quit. Let's learn how to quit this software. To do that, we go up to File, we click on Quit R Studio, and you get a pop-up that says, do you want to save the workspace image? Well, if you haven't already done it, you might say, yeah, I do. Since we just did that, we can say, oh, don't bother to save. I've already done that. So we'll click on Don't Save. We don't need to save it again. And our Studio quit. So let's start it again. and this will teach us how to launch it. We once again launch RStudio. You can see that what it does in this case is, because we left RStudio with this script open in its script window, when RStudio relaunches, it relaunches back to the same script window that it started in. You can actually open several scripts at the same time. You'll get different tabs showing up along the top here and move from one script to another. You see that the workspace over in the upper right panel is empty. If we want to load that workspace that we built, that we set up before, we need to go back down to the file system now and set up that working directory again. Remember how we did that. So let's go down to the lower right panel. Let's navigate to the webinar directory right here. Click on its name. There in the webinar directory, we can see our script and our data workspace. And now let's click on More to set this directory as our working directory. Set as working directory. And now any more actions with files that we take during this session, the files will be read to and read from this webinar directory. To load the workspace back in, we just click its name, and you get a file asking, or a pop-up saying, do you want to load that into the workspace? Click yes, and the workspace comes back. Okay. So what we've just gone through now is the basic functioning of working with script files and workspace files, starting and stopping R in RStudio, building a little script. Let's stop for a moment and see if people have questions.
Okay, we do have a couple questions. One of them is, do you have to set the working directory every time you open RStudio?
I think it's what I do. Now, it's possible that in R or RStudio there's some kind of a switch you can set that will I know you can do this in R. Here's an example. Okay. You see this command right down here? Set working directory webinar. We can take this R command, highlight it. That doesn't work so well. The way I do copying, I want to copy this little line of text. So I highlight it, then I hit Control-C. That does a copy. I could go up to my script, hit Enter, and put a line in front. If I now right-click, oh, that doesn't work either. All right. Now, I can do Control-V, which is paste, and I've entered that as an R command. So one of the ways you can do this is you can use the R command itself to set the working directory, and you can identify it in your script. That's one way to do it. It's possible that in RStudio there are places that you can automatically get it to open a particular working directory. I haven't figured that out myself. Any other questions?
Well, we had someone ask if you could please explain the workspace or environment, what it contains, and the functions.
It contains whatever you put into it. In this case, we've only defined 3 variables, X, Y, and Z. So anything that you name, for instance, when we read in a data set into R, what will happen is that R will make a copy of that data set and not disturb the original file and store that copy in the workspace. If we define a new function, which is fairly advanced, I don't know that we'll get to that, that function is stored in a workspace. All the things that we define where there's a statement that looks like this, z is equal to, or z is assigned to be x plus y and y is assigned to be 4, all those things that are on the left side of assignment statements end up in the workspace until you delete them. And we're going to do a few, since we have time, we're going to do a few more commands to show you a little bit more advanced functioning, and that'll show you some new things that show up in the workspace. Any other questions?
I do. We have another question. Someone, Kara Clark, it says, I have used TINN, T-I-N-N, capital R, in the past, and it looks like the files from RStudio are being saved as TINN-R files.
Yes, TINN-R, what TINN-R is it's essentially a separate program that works as a special text editor for R. So it's essentially a program that runs this upper left screen. It's a text editor, and that means that its files, its text editing files can be loaded directly into RStudio or vice versa. They can be loaded into a Notepad or WordPad or Word for Windows, any of those. It's just, all it is just a environment for doing text. TINN-R also has a window that you can click on Run, and it'll send the the commands to an R console. So it kind of works the same as this upper left panel. It's kind of an older version of this upper left panel. Any other questions?
Yes, there was another question saying, so if you save the workspace, you don't need to type the commands in the console again?
Correct. We don't need to type the commands at all because we've got them stored in their script. So we don't have to run those commands. You could run them again. Essentially what that means is that if you execute a series of commands, 1, 2, 3, 4, down these commands, and you stop right at this point and save the workspace, when you open up our RStudio again, you can start and load the workspace. You can start right at this point with more commands because you've already created these commands have already been run, and the things that they created are still in the workspace.
And that may or may not have answered this next question, which says, couldn't you just run the script again to create the workspace? And why would you need to save both the script and the workspace?
You don't need to save both the script and the workspace. And for this particular simple script, I wouldn't bother typically. The reason I'm showing you how to save the workspace is that in the workshop, the NARS workshop, we're going to create some very big, complicated objects in the workspace. It's going to take us a long time, like an hour or at least, or 2 hours to work through a script. And when we're all done, we don't want to have to do it again next time we start R. So we're looking ahead to the workshop. Anything else?
Not at this point.
Okay. All right, we have a little bit of time left, so let's do something that's a little more interesting. These are really Mickey Mouse commands. Let's do something a little more interesting and show you another couple features of RStudio and R. Let's do an example. I'm going to enter a comment line here where we're going to create a vector of whole numbers. Oops, typed it wrong. Sorry, my typing is not very good. From 1 to 11. And to create that vector, and we'll call that vector x.var with our assignment symbol, and we'll use this function, seq, open parentheses, 1, comma, 11. what that command means is this thing on the right is an R, what's called an R function. SEQ stands for sequence, and it says create a sequence of numbers from 1 to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Take that sequence of numbers and assign it to have the value x.var. You notice that what we're doing now on the left side is we have a more complicated name that's got a period in it. And that's a useful device, as you'll see in the workshop, for helping to name variables. When you do a big complicated program, you get lots of variables, and one of the tricks you learn in programming is how to name those variables in a way that you can look at them and recognize maybe what they mean. So you can use a dot in the R language as part of a name. Let's execute this command. Sorry, I've got to highlight the whole thing. Yeah.
There was a quick question, John, and asking if you could explain what is meant by the term vector when you had create a vector.
The best thing to do is to run it, and we'll see what a vector is. So highlight the command and then click Run. And you see up in the right side is the workspace. It's integer box 11. That means it's an integer vector of length 11. And to see what it actually is, how do we look at what that thing is we've created? How do you look at anything you've created? Oh, shouldn't have done that, should I? Sorry. Let me put that back in the script. I'm just copying it back from the command line, back up here. The way you see anything you've created is you type its name and just execute the name. So we type the name into the script, execute it, and run. X.var is what's called a vector, and a vector is math jargon for, think of it as a column of numbers or a column of values in a data set. The word comes from vector matrix algebra, which is what one kind of algebra and mathematical calculation that R can do. So its jargon for a single column of numbers is the word vector. Now, when we display it on the screen, it's a row, isn't it? It's not a column. But rest assured, it's stored internally in R as a column, and it operates algebraically like a column of numbers, like a vertical vector in vector matrix algebra. So we created this thing called.
Go ahead.
Yeah.
I had someone ask if vector is a one-dimensional array.
That's correct. It's a one-dimensional array.
Okay.
That's exactly right. Now let's make another vector in our script. Let's calculate something from that first vector. We'll call it y.var, and we'll assign it to have the value of, this time we'll hit an open parentheses, x.var minus 6. You notice that RStudio gives you a closed parentheses whenever you do an open one. So go outside the parentheses now, do an upper caret, which, as you know, well, maybe you don't know, it stands for exponent. Raise it to a power. So we're going to square that thing in the parentheses, and then at the end we'll add 2, plus 2. Okay? So y.var is equal to x.var minus 6, that quantity squared, plus 2. And I hope that you can imagine what that calculation looks like if you were to write it down in algebra. Y equals x minus 6 quantity squared plus 2. The thing that might be confusing is, well, the trouble is that what I'm doing is a calculation. This is the kind of a calculation you'd expect for a single number. But what R is going to do is it's going to take each element of x.var and apply this calculation to it, one after another. So it takes the number 1, subtracts 6, squares the result, and adds 2, and puts that as the first element in a new vector. Let's actually run this, and you'll see that. Highlight it, run it, and now display it. Okay. So what R has done is it's taken the number 1 and put it into the equation, done the calculation, it gets 27. Then it takes the number 2, puts it in the equation, done the calculation, gets 18, and so on, all the way down the line. So it creates a new vector of the same length as the old one, and this is the relationship between the new one and the old one. Okay? So this is an example of a little bit of vector algebra that R does.
We just had someone ask John, how do you make a sequence that has an interval less than 1, for example, 0.5?
Okay, let's figure that out. How do you make a sequence that's different from 1? Well, Seq is an R function. So to figure out how to do that, we need to find out more about Seq. And to do that, we're going to go to the help function of R. So let's go over to the right-hand lower panel, and you see there's a help tab. If you click on the help tab, it brings up another window that you can ignore for the moment. But now go over into the little search box. You can see it over on the right in the upper part of that tab. You see where I am? And type the name of that function, SEQ, and hit enter. I'm going to make this window bigger. Okay? This shows you how to use the sequence function. And it shows you the form of it. There are various forms. From equals 1, that's where you start. 2 is where you end. By is the interval you want between it. I think that I'm not sure if the sequence function will use non-integers, but there's one way to find out. We can go back over to the console and try it out. Can't hurt anything. Let's go into the console and just type sequence, comma 1, comma 11, comma 0.5. See what that does. Yeah, that worked pretty good. It does do it for non-integer numbers. The main thing that I wanted to illustrate with this example is the use of the R help system. There's a tremendous amount of information in these help files, and the trick is to be able to find something in them. In this case, we knew there was an R function called SEQ, so we could just type its name in. But suppose that we have something where we don't really know what the name of the R function is. We just want to know about how to do something. Let's take an example. Let's go to the back to the search box in the help system, and let's suppose we think, let's see, I want to figure out how to calculate a correlation coefficient in R. So I'm just going to type the word correlation into the help box. Oops, spelled it wrong. Like that, and hit enter. And what comes up now is a list of all of the various kinds of functions and locations that R does that involve correlations. And you can just look at that list and see it gets pretty complicated. The one that we might choose to use is you read through all this complicated stuff, and down here it says, oh, there's something called a correlation coefficient. That's what we want. So to get help on it, you just type its name, or just click on its name, and this is a this is, oh, that's not quite what we want. This one does a weighted correlation, although you could live without the weights. Let's go back and see if we can find another one. We just hit the back arrow.
So John, one of the questions might tie in good to what you're showing us now was,
yeah, the one you actually,
is there a good reference document for all these R Studio functions? Is this a good place to find that, or is there another area?
these are functions in R, not RStudio.
Okay.
We're working in R, and RStudio is just the box inside where we're working. But let me put it this way. R is a monster. It's enormous, and it has an enormous number of functions. And there are something like 2,000 add-on packages to R that do a huge variety of statistical and mathematical calculations. In the second workshop instruction installation instruction file that the attendees received is a list of some some R resources at the end for beginners. And if you look in there, there are some books. So there's some aftermarket books that show you some of the basic statistical functions of R. There's also a huge book. It's about 700 pages. It's called the R Book. It's by a guy named Crawley, C-R-A-W-L-E-Y. And that's kind of the Bible of standard operations in R. So I encourage you to do to use that kind of a resource. Another very good resource for figuring out how to do stuff in R is to Google it. For instance, if you go to a Google search box and you type correlation in R, you'll get all kinds of instruction sheets that are part of university classes, for example. There's lots of really useful examples and little vignettes that show how to use various R functions that can be found by Googling. That would be a one way to start. I hope that answers the question okay. Oops. Okay. So we've seen an example of the R help system. Let's just do one other thing. I think we're about out of time. We'll do one other thing. Let's go back up to our script and let's just make a scatter plot of X and Y to see what that relationship between X and Y looks like. Here's the X values, 1 through 11. Here are the Y values. And those of you who remember your analytic geometry when you studied calculus will be able to predict what this relationship should look like. To view the relationship, we'll just plot it. Let's just do plot. Put the X variable on the X-axis and the Y variable on the Y-axis and run it. And in the lower right window, the plot appears. By resizing the window a bit, you get a pretty good sense of what that plot is. It's a parabola, which you knew from the equation, right? It's just plotted the X variable on the X-axis, the Y variable on the Y-axis, and it's labeled them with their variable names. But you can, this plot function, if you do help for the plot function, you'll see there's a tremendous number of modifications you can make to the plot. You can use different labels and different tick marks and connect the points by lines and use colors and on and on and on. So this is an example of just making a simple plot in R. And in this plot tab window, there are also facilities for exporting these plots so you can send them out to JPEG files or PDFs or whatever. I think we're going to do a little bit of graphics in the workshop, but not too much. Anyway, there's this whole plot facility that's involved with R as well. Okay. I think that's all the new material that I want to present at this time. I want to stop for questions, and then I have a few closing comments. So are there any questions so far?
There was a question, if a comment wraps to a second line of text, does the second line also need the pound symbol at the front?
Let's see. Oh, the blank line? Is that what is meant? This line right here?
Let's see, it's
Not sure
from
what they mean by that.
Megan. Let me see if I can unmute Megan here.
You can always put blank lines and they're just ignored in the script file if that's what the person is asking.
Megan, I have you unmute. You're unmuted, so I don't know if you want to ask more of what your question is.
Or can you hear me?
Yes, I can.
Yeah.
Oh, great. So let's say in one of our comment lines where we have an example showing that R is case sensitive, if you were writing a lengthy script where you really wanted to talk about what you were doing or why you were doing it, and it went more than one line, do you need to continue putting that pound symbol in front of each line that the comment goes into?
Excellent question. Yes, you do. If I just run on, if I type enter and then I start typing this example is a simple one, you notice that on the next line the color of the text is different. R thinks that's going to be a command again. If we try to execute that line, it tries to execute it. It thinks it's some kind of a command. So every single line that you want to be a comment needs to begin with a pound sign, like this. To my knowledge, R doesn't have the facility that, for example, comments are available to you in the SAS language, where you can put whole blocks of text without intervening symbols. I don't think you can do that in R scripts. But it's easy enough just to type another pound sign. Any other questions?
We do. We've got a couple. In the workspace screen, what does the import dataset button do? Is this like the read table command? I'm sorry, command.
Let's see if I can. The answer is yes. That's exactly what it does. There's a command in. You'll see this in the scripts that we're going to use for the workshop. We do a command called read table that reads a spreadsheet-like data set. And the import data set command is a way to do that in R without having to execute the read table command. I'm sorry, a way to do it in RStudio. We're not going to use the import data set command for the workshop because we're going to read several data sets all at once. And it's kind of inefficient for reading several data sets. But if you have a data set of your own, experiment with importing it. This import command will import all kinds of data sets, tab delimited, comma separated values. I don't think it will import direct Excel spreadsheets. I think they need to be saved out as text files, either as tab delimited or commas delimited to be imported. Other questions?
Sarah asked, going back to Megan's question on the comments, she said, is there a maximum width for those comment lines?
No, you can just keep typing if you want to. Since you're working inside this text editor, the only thing that might happen is, I've never really tried this, but if you just keep typing, the text editor might wrap the line onto the next line, and if it shows up as a different color, then you got to stick a comment in it. I often write comments where I'll do something like this. Incidentally, one of the things you're going to see that's not shown in this script is R is pretty smart about where you end a line of command or comment, but I'm not. So I want to let myself know where I'm done with a line, and I do that either for a command or a comment by using a semicolon. So for example, I'm ending this comment line. Now I go on to the next one, and I can type another pound sign and then put case sensitive. Just carry on with the sentences before. that's how I use comments myself. And you'll see in my scripts that there are semicolons at the end of every line, just so that I know when I've stopped. And the same thing applies if I go down to a command. I'll put a semicolon after the command to say, yep, that's the end of the command, John, just so you know it, and so on. It's the end of that single line of information. Any other questions?
I think we've had this asked a couple different ways, and hopefully it can be addressed. So given the extensive nature of the R functions, is it possible that you can that people can get a recommended set of functions for the routine environmental data analysis? For example, Aaron asked if season Kindle testing, power analysis, random sampling design, those kind of things.
Well, it depends how many hours of workshops that people want to attend. Those are each of those is a big topic. What we're going to do in the workshop is we're going to do a fairly limited set of analyses in which we learn how to make the kinds of estimates of the percent of systems that are in good, fair, or poor condition, or build a CDF reporting the kinds of estimates that are showing up in NARS reports. That's what the workshop will consist of. That will be its goal. Along the way, we're going to learn some R commands for doing some of the analyses that people may be interested in. But for example, we won't do power analysis. We won't do some of the other topics that are mentioned. Those have to be left for people have to find those on their own resources. And I think those aftermarket books that I mentioned, and also Googling for topics like how to do power analysis in R, there's probably a whole book on that about how to perform power analyses in R. So that's something for you all to learn.
Are there any other questions before John wraps up the webinar? Okay, doesn't look like it, John. Sarah, I have you off mute too. Is there anything you would like to add before John wraps up?
No, I just want to say, John, thank you very much. This has been great, and I'm really looking forward to the workshops, and I suspect that all the people who are muted are also looking forward to this.
Yes,
so thanks.
They are. So I think we're ready to wrap up, John.
Good. Okay, well, I just have two final words I want to mention. First of all, if you haven't done so already, I'm assuming again that you've all got R and R Studio kind of up and running on your computers. If you haven't done so already, go on to the second file of free workshop instructions that Tammy has sent out, and make sure you load up those NARS data sets. We're going to be using data sets from the National Lake Survey of, National Lake Assessment. I'm not sure the year, 2007? I'm sorry, Sarah, I don't remember the year exactly. But it's a data set that's on the NARS website. Yeah, there's several data sets we're going to, so download those onto your computer and put them in the location that's mentioned in the instructions. And also, put the scripts that were sent as email attachments in that same location as the data sets. And then if you have time, you can spend a bit of time, if you'd like to learn some more about R, looking at some of those resources that are at the end of that second pre-workshop set of instructions. If you want to get some more tutorials or want to look at some aftermarket books for learning some basic functioning of R. The second thing I want to make a note about regarding the upcoming workshop is that the workshop is very focused on the data analysis of a particular set of data from a NARS sampling effort. So that means that we're going to assume that you already are familiar with the NARS program, with its goals, and with the the basic concepts and methods of field sampling, the concepts behind the NARS designs, the idea of using unequally weighted sampling and unequally weighted data. If you are still about hazy about a lot of that, I recommend looking through the some of the papers that are cited in the NARS Lake Assessment Report. I would recommend reading that Lake Assessment Report and its technical appendix to refresh your memory about what's going on with these surveys. Because our starting point is going to be that you've done one of these surveys, or that you know about these surveys, and what you are really interested in is doing a similar kind of analysis for a smaller area. It might be your state, it might be your ecoregion. That's where we're at with the workshop. So if there aren't any more questions, I'm finished. And thanks for your attention. And I look forward to seeing you in Cincinnati.
Great. We appreciate your time, John. You had lots of great comments, and was very helpful, and everyone appreciated your time. And I do want to let everyone know that I will be sending out probably next week. John will be available in the mornings before the monitoring conference during the breakfast hour, and we've kind of set aside an area for that. So I will send you all that information and instructions. And we do ask if you could check in with us that we know you're there and your computer's working great, and any other questions that can be addressed. And also we've tried to honor everyone's request on the day of training. We haven't had to move everybody, so your preferred date of training is the date you're being trained, but again, that reminder will go out along with making sure, as he mentioned, that the data sets have been downloaded and installed. So we appreciate it. Thank you. Thank you, John.
Sure thing. Take care, everybody.
All right. Bye.